All right. Okay. Finally got it. I didn't know there was this part, but yeah. All right. So, welcome. This is the restart or the reboot of uh, yes, which is the programming stream, where essentially you just write some software together. Uh, I kind of choose the topics, but other people can chip in. Just like if there's a topic you want me to explore, just let me know. Uh, you can also tell me how experienced you are, and I'll try to accommodate explanations towards that. So today, we're going to cover PDB and Golang. So I worked at a bioinformatics lab for about a year, and one of the things that annoyed me a lot was just kind of what felt like how rudimentary all the all the software was. Like for instance, so I understand like everything is supposed to be like a text file, but the PDB files were all things you needed to go to a website and manually download. And the website I'm talking about is I think it's yeah, it's right here. This website. So you'd always have to go here, uh, download, and then yeah, you can go to this website and then give it a list of PDBs, which is protein data bank files, and it would download them. And I thought that was kind of annoying. But they have a GitHub. Maybe it did something. Weirdly named. It's written in Go. Is it? Oh no, this is just a Python. Okay. But yeah, so it was just annoying to have to download all of them. So today I kind of wanted to see if it were possible to just programmatically download it instead. But let's see if they had. Okay. Okay, so they're saying web service APIs are being developed. Users should register with their API list for announcements. I'm gonna try and see if we can do this without having to register anything. So PDB is protein data bank. So it's essentially if a scientist uses something like NMR techniques to find a new protein, the PDB file is what encodes each atom's location. So in 3 space, it'll say, oh, these are the coordinates of this carbon atom. The next carbon atom is here at some coordinate location. So I'll show an example of the. So let's go to 6Q8T. The naming is also kind of strange. But yeah, so this is an example of a compound, and you can display the PDB format. But yeah, uh, the title, the molecules here. There's some metadata at the top. I believe they'll name the authors. Yep, right there. The journal is in, some comments about it. And then we and yep, they start describing all the atoms. So this is atom one, it's a nitrogen. Not sure what that is, but these are the coordinates. Well, these three are. Let's see if there's like a format document that describes it. Okay, there's. Yeah, it's usually for macromolecules derived from X-ray diffraction and NMR studies. And it was made in the 1970s, so it's been a while. Yeah, and a lot of people don't transition away from it because there's just been so much written about it. That's kind of what like JavaScript's like, where it's not that good of a language, but because so many people use it, you can't really get out of it. Yeah, let's see what the documentation was. Ooh, 200 pages. That's a experimentally determined three-dimensional structures. Oh, okay, so this is telling us how we can handle characters. Only non-control ASCII characters appear. Good. Characters are spelled out. Bullets are presented as dot. Left arrow. So they use a backslash for comma, colon, semicolon delimiters. Okay, even before we're parsing, this is just kind of what PDB is. Even before we're parsing that, we want to make sure that we are able to access it. So normally that would be here, and we go click this PDB format. So if I'm gonna copy this link and see download. Oh, okay, that's great. So what we can do is we can probably send a request to this URL and then take the string of whatever PDB they want, end it with the PDB. And we can just send a request there using the Golang's library, and that should do it. I think if we press enter, it'll download it. Okay, that's good. So we got the down. I think that gives us a hint of the downloading part. So let's actually. This yeah, I'm just gonna call it PDB. Initialize it. And so I'm gonna create a few notes about what we want to get done. Right, so the first thing we want is, so what are the steps of someone programmatically accessing this? So an example would be they're writing some code they want to do. Protein A is pdb.get maybe, and the name of the PDB. So in our case, it 6Q8T. 6Q8T. And now, somewhere, whenever this executes, it will get to that and store it in a temporary file. And protein A will be some kind of type struct that holds the location of the file that contains 6Q8T. Another thing we need to do is make sure we kind of normalize it, make it lowercase and whatnot. And the reason we're doing this is because it's kind of annoying to go to this website and have to individually download every protein. So I'd rather just do it from here and then make use of that. And this is okay. The URL was something like we'll take F. So we'll replace this F with whatever string they give us. Yeah. Send a request there. Yeah. And ideally we'll place it in, we'll create in the location, actually in temp, in whatever temp there is, so we also have to make this we should make this operating system neutral. So maybe Golang comes with a tempter, like a temporary directory variable. Let's see. Oh, they do, great. And Unix systems, it's /temp. Windows, it uses get temp path, returning the first. That great. So we can just use func tempter to get the tempter get a location where we can create some kind of PDB directory and then store the contents of that download there instead of just putting that in or like in downloads. So that's just kind of like the first few steps we want to take. So this is our main binary, but we want it to be more of a library, so this will kind of be, this won't be package main as much as it's package PDB. And then we don't need format yet. We don't actually need any of this. So we can create a few comments about what kind of functions we. Okay, so we want to create a type for PDB. Struct. Here, it should have a name, obviously. String. And it should have a file pointer. So this will just be the name of the protein. Review this. Yeah. Here we'll add a comment. Name of protein. And here, should we have a file or the name? If it's a get, well, I guess that depends on how the API gets used, but we have a. Actually, if the file isn't open, then we should open it. So let's make it lazy. So how does it go? Handle files. Okay. I have. That would read. Okay, so we'll just store the path then, the full path. Absolute path to that PDB file, and then we want to have a func. Okay, so normally, well, when we originally did this, so we said we would just get it like this, as if it's some kind of function we can call, and then it would return this struct. So it's kind of like a constructor. So whenever we interact, so protein A is the instance of that PDB struct, and attached. So PDB get is almost like a constructor for protein A. And then anytime someone interacts with protein A.read, it should redirect to file.read. Or later on, we'll add more method, like relevant methods that PDB would. So like position of atom and it would return a vector, like an array of 3. But for now, get is a constructor, A is a PDB struct. We also need to find a way to test the contents. So we should, so let's look at this. See if there's like something on the top that we could parse that would tell us this is it. This is you've read the correct file. So I guess what's specific to 6Q8T, 6Q8T, I guess we could do some partial parsing of it. Yeah, we could see if we get this first line. Oh, first line contains 6Q. So we should have a method to get header. So protein A get header should be a thing. So this get should take in the name of the protein, and it should return a PDB struct. And then PDB type attached to any instance of a PDB, we want this function that can get us the header. And we want to make it capital to make it public. And it returns a string. And this allows us to test it. And we should just get hydro. Actually, let's see what does a header contain? Or what is it supposed to contain? That way we can. Contains PDB ID code, classification, and date of deposition. PDB ID. So we'll get the ID and the date of deposition just for now. From this PDB, we want to get the date of deposition, and we want to return some go time date type. Okay, time.time. Okay, so we can return with time. You'll have to import time. My terminal froze. Really, so I press Control X, Control O. Tmux. Okay, no. Disappointing, but I have to close that. Okay, it's gonna complain. Oh, okay. So yeah, so we want to import time. And we want to return from get data deposition time.time. Okay. All right, so for these we can possibly do later. For now, we want to do this get command. So one thing we want to do is we want to create a. We want to get that temporary directory, right? So we want to import OS. And later on, we want to, whenever we call get, this is better called ID, I think. ID. This should just return ID, but we don't need a method for that. But this is something specific to that file that we can test. So we removed the ID get ID method because that's just something that they supply here. ID, and we return a PDB struct. Here we want to do the work of creating. Actually, we'll have this just create the struct, and then we'll have a private method to lazy download our PDB file. So we'll call this download PDB file, and we pass it a string, and that's when, and we'll have it return error in the case that it can't actually construct it. So get should just construct PDB struct yes, and it should set ID equal to the ID passed in. An absolute path should be os tempter slash PDB slash the file.pdb ID session. So Steve going string cat. What does that look like? Okay, so you could just, okay, that's great. You could just add it. So we want to do this dot tempter, which is a function called that, I believe, if I remember correctly, returns a string. Good. And we add it to, it'll be slash temp, and then we do that. Actually, is there a better way to do this? I'm pretty sure they'll have a concatenating paths so that we can account for this slash. So we'll have to make dir for sure. Move rename. There is something we need. Change directory. Change. So we won't create the directory yet. So we'll just do slash PDB slash the ID as a string, which is already here, plus .pdb, and that gives us the file path that we want. And we want to just return this, so we can just leave return PDB, return that, great. Oh. Okay, it's just deleted everything, great. Alright. That is disappointing. Wow, okay. So we had time here. We change this to ID. We don't need this. Okay, I really need to. Okay, I need to clear that temp directory. So it's vim temp. Don't you love it when your tooling breaks when you don't want it to? So if we remove. Okay. Okay. All right. So let's remove files here. Jesus, man. All right. Oh. Oh, okay. So, oh, wow. Part of it is here. Very great. So we had OS time, absolute path. This is what got deleted, but the spacing's also weird. Maybe it's okay. Here we took in the ID and we return path equals us dot tempter is the ID plus file extension. We should make this. Actually, I think this last part is fine because I think when you download it as a PDB, but this we should make a variable in the case we change it. So var PDB tempter string equals /PDB. All right. So temp started with just a slash. We should probably be consistent. Yeah, we should be consistent. Is there a join path? Join path. Join path. Path. Okay. Join. Nice. Okay. We can just use. Oh yeah. Let's use that. That's in a separate. Path.join. Join. All of these are arguments. They're all strings. So let's do this. .pv, good, great. So we can just do that. That's a better solution too. And then get ID. This is the thing we didn't need, so we'll just get rid of it. Here we want to return time object. Actually, we have a choice. We could put this. So currently, if we just return PDB, pretty sure I'll put it on the stack. I think it's better if we return a pointer to it, which will put it on the heap. Tempter type disappear. So now that just creates a struct. So when you do get date of deposition, you should check if that thing. So we'll have a downloaded bool so that we can lazy download it. Right. So if not down. We'll download it, then set p downloaded to true. And then from there, we'll read the first line. And we'll cache it too. So I guess we could just do date of deposition. So this looks like a common, it's a common check. So this should likely go in its own function. Download. Oh, we discussed this before. Download, and it should be attached to the struct itself as a private, which will do the check and of if it exists or not. Download here, and if it doesn't exist, we do the call here to get it. Set that to true. Should be good. On repeat calls, this will short circuit because this is set to true. There are multiple threads accessing it. There were 2 threads accessing it. Need it around. I know this isn't a problem yet, but something to just think about is thread safety for the PDB type, which couldn't be a common problem. Or we could put this in a channel in each. This should be read only. So it'd be the one place we use a lock. But I think using a lock is something Go don't really. So we can just try it for now, and then add it to do something about it later. So that's in the sync. I believe. Sync, and then they call it mux. Okay, is there a Go format for this? All right, cool. This is saying at line 24, I'm missing a. Oh, yeah. Okay. So we have this mutex just for the download method, I think. I think my tab sizes are too large. So if we go to, let's fix this just really quickly. Config, UVim, init, S2, tabs are spaces. It should be 8. Now if we do Go format. No. Oh, I see. All right, so there's a. Let's see if we can. Tabs are. We don't. Okay. Okay. See. All right. There we go. I think that did it. Unless we rerun it and it fixes it. Oh no. All right. That's good. So here we want to get the lock. So we do p.mux.lock. We defer the unlocking, which just as this function returns, it will release the lock. Right. Request. And that way, anytime someone tries to access this, first it will lazy load it, and then people can access it. And this lock gets kind of used only once. That makes me question whether we need. someone is just downloading it, why not just I think actually let's just get rid of this lock. I don't for using something just once, it's not really a good idea to just add a ton of download it. We'll just download it. I think we need to do lazy loading kind of stuff. So we'll download it there. We'll get the date. Then also get should kind of set that for us. Loop path, something we set, data deposition. We'll extract that. So if we slowly expand this PDB struct to include all the things that a PDB file contains, lazy loading does sound a lot better, so maybe let's just put everything back. We'll keep this for now, but I'll add a to-do saying this gets used once. Maybe delete it? Get rid of it somehow. And here we download it. So this should just be a getter almost, right? Make sure you download it, and then this will the time isn't set. So if someone, okay, so there's a difference between getting downloaded and read. So that way, we have a download. Actually, we'll have download do both, I guess. So in this case, when we download it, we'll parse its data to and set get data deposition, downloads this check, and we'll just return a date of deposition. Here, data 2. Alright. We have some structure to this mess. All right, so now we want to send a request to an HTTP request to that URL to get content. So we want to do a get constant. Is this HTTP? Yes. Okay. This is the URL. I think a get should be fine. Yeah, let's print this first. See what is there a Go playground? Yeah. Cool. We want to do HTTP. we want main be response error, and from HTTP get. HTTPS, and then 6Q8T, was it? 6Q8T. Here, body, and straight up. Line 9. Oh. Build arguments. Download HTTP malformed module path. Oh, maybe they don't actually allow that. All right, so let's just open our own. Oh, nets. Oh, fair enough. Oh, right. We want to get IO. Oh, IO slash I. So we don't use this. Actually use this either. So we want to do this. The underscore just variable that gets thrown out correctly. Oh, cool. So it gets it. So there's no problem with. You also want to make sure that the top. Okay, so it just gets. It literally just gets the text, so we can just read the first line. Okay, cool. So, go. Great. Here. We have. Response and an error. We probably want to return this error too. Hopefully it's nil, but you never know. Error. Oh, no, that's the right form. Error. Okay, it is. All right. Right, that's better. So I'm going to add the full word there. And here We receive, we send that HTTP request to URL, apply that in if error or if error not equal nil, so that means there is an error. Let's just return that error up to the parent scope and then let it decide how to handle it. Because we don't want to just add our own information. That's not useful. In this case, if there's an HTTP error, just the parent scope should know. But if that's okay, we read the body. Process for error again. Body. And if we encounter this, just go up. We want to add IOUtil in net. Then net slash HTTP. Cool. Or so we read the body. We want to get a single line from the body just from I think just for now, let's go read one line. Buff IO scan. You construct it you construct it to an IO reader. I believe response.body is an IO reader. Make sure. Response.body. Body is an IO reader, great. So we can just open a new scanner. In that case, we don't need IOUtil. We do need IO. And just return to scanner. New scanner, but we point it to response.body instead. And see if I do that. Right, so it should read up to the new line, read to that input, scan, run, find strings. Okay, so this is an example of how we could read it. We create a scanner to it, so we have that. Oh, okay, so by default it will read it, I guess. All right. So we can just read, oh, it's scanner. I'm gonna make it, no. That way we can access it later if we need to. Now we want to just read one line. Wait, can we also, there's a way to test whether it fits. So we don't need a for loop, we just gotta do, actually, we gotta call scanner.scan once, I believe. That gets us scan. Scan text. This gives us the actual text that we can parse for a date. So here we should do some kind of regex. Actually, no, we should do that here because that's not specific to this. All right. So if not downloaded, it's downloaded. Great. And we have a scanner to it. We should, oh, there's something, you gotta defer the closing the body. Body close. Okay. But we should write this to that file. I don't think it's doing that for us, it just gets it. Okay. In that case, oh yeah, this scanner will break once this body closes. So let's not have a I guess download should just download it into this absolute path. Yeah. So we have an IO reader, what body is. Right. Body's an IO reader. Let's see if we can somehow send okay. Hmm. Okay, so we can just use IO read all then write it. That's better. Or it just works. Body. Detail. Okay. Cool. We've read that. Now we have this. Now we want to create an output phase. IO to p dot I don't know what that. No. Let's use. I'm gonna do p dot absolute path. I'm gonna write body 20644. This and an error does not equal nil. Return the error. So download does this check. Now we want to check if we open the file and then just get the first. That's what. Actually, let's just consistently use IO, I guess. So in that case, for IO new scanner, scan and then write it. Now let's just, and then here we'll create a new scanner. Equals IO scanner. Create it to file area. So PDB file here. PDB file p.absolute path. Return it's time with just that returns a default, but then they'll see that there's an error and they'll short circuit it hopefully. So we open a new scanner to that file handle file, or scanner. Now we want to scan just one line. that's scanner.scan. Now we want to do a regex match of just that first line. Right, so it would be two numbers. Is it always that? We want to match it. Date of deposition. That is mandatory. Interesting. Okay, so it's always seems to be dates. Mhm. Comes first. So if it's from here, it says the column 51 and 52 are going to be the day dash 50. We have day, month, and then year. So that's 51, 52, 53. Okay. So these first two are numbered. The first two characters are numbers, last two are numbers, middle three are letters, and then there's dashes. So we want to make a regex somehow match that. So let's see. Nice. Great. Go has a lot of nice. Its standard library is very nice. Also, just how it organizes is really nice. So we have right. We'll construct the regular expression once at the top, and then we'll compile it once, and hopefully have to do pointer to date regex. This initially nil. Actually, no. Let's do. I only need it for once, so let's just do. Regex. And then here. Compile, and we match numbers. Oh, it uses RE2. So we want to start off with two numbers. Character digits. Good. So it'll be /d slash d dash capital letters only. Oh, okay. So we'll do. Try to solve a problem with regex, you now have two problems, right? So we want to do through z. Z. 4 of them. Oh no, 3 of them. Z. And then another 2. Okay. That compiles our regular expression matcher. Yeah, it gets used. We want to do a match, I believe. Find all, no, just bytes. Find string. This is the content. See if we can find with the scan. Oh no, scanner.text is a string, so we'll just do find string. A match. No, I guess we could just use must compile. Good. Cool. Do find string. We're passing in scanner.text. And this returns a string, I believe. That, and then now we want to see if time.time has a string-based constructor. Of course. Month day. Oh, oh yeah. Yeah, like the format that PDB for some uses is completely different from all the standard ones. Oh, thanks. Good work, guys. So we have the first two characters are the day. So we need to actually. So now we have the date. Day, I guess month. Hmm. Month is usually in and then you could. We have it as a string. Let's see if we provide a. Let's int going. Hmm. We kind of have to provide our own method for that. The day, you can know the year. The day is pretty easy. It's just first int. A lot of libraries. So here we use string conv argument to integer, and we pass in the first two characters of the date. Meaning just before. Okay. So that's that. And the year. Oh, this one's gonna be weird. Because could there be PDBs before? Yeah, there could be PDBs from 1970 all the way to now. So the range is 70 plus and 2020 less. If if it's between the range, if it's between, okay, so if we read the string and if it's between 70 and 99, then we know that it's in the 1900s, 1970, 1990. But if it's not between that, assume it's in the 2000s. Dating format's pretty bad. I mean, it's not going to last. It's exactly this date. It's just not going to. Anyway. So year will be 1900 plus. Actually, string convert returns an error too, so probably use that. This will be, so this is 0, 1, 2, 3, 4, 5, 6, so 7 up to the end. So we can just do, I believe, so it's 7, then delete this letter. I think that should do it. Now we have that end part, but if year is less than or equal to 99 and greater than or equal to 70. So if it's in this range, let's call something else. We add 1900 to it. So now we know the year. Else, we add 2000 to it. Okay, now the month is just comparisons. X. Go compare a lot of strings. Let's see. A lot of strings. Is there anything cool here? Compare. Oh, so you can switch case on it. Oh, okay. Switch. Oh, bet. Switch will work with non. Nice. Okay. Switch on. We're doing date. So 0, 1, 2. So 3, 4, 5. So dates 3 to 6. 3 to 6. Purpose of. Oh, I see. Okay. That. And then the case where it's nasty. Oh wait, time, what does it need? Year, month. So we have the year and the day, now we need a month. So we'll just declare month. It's timed out month. Oh, so these are just okay. In that case, month equals to timed out January. And they'll just run the case. We don't need to add a break and things. That's nice. Yikes, this is not fun. This seems very rote, but Oh, hi, Sol. Hi, Kristen. Well, my friends. We're good friends. We don't have a standard date format. Ugh. PDB dates. Oh, not deposition. Deposit date. Wait, no, they called it deposition. This. Date. Nope. All right. Let's just assume that. Imagine this is July. October, November, and December. This is very much a case where, like, if you had like a AI bot with you writing code with you, to go like, "Hey, I'm noticing this pattern. I'm just gonna finish the rest for you." No, very much could have been the case, but not happening. Right, we're finally done with that. Please. And now we want to construct the time. Oh, date rather. And that gives us. Then we're just going to use. So date of deposition or depositing. All right, is time dot date. And we have the year, month. We have the day. We don't know anything else. Day, hour, minute, second, nanosecond, and then dot UTC. Then so we want to do P dot deposition, storing it. And we want to return that exact time. All right. All for one method, really? All for just getting the date. We wrote, I don't know why everyone else would know it. September. Okay. We wrote 103 lines for just a date? Whatever, fine. So now we'll write a test. Test. They just fill it in. Test in PDB. Test. Get date. Okay, so what we need? So we want to get a protein equals PDB dot get, and then we'll get this wonderful 6Q8T. 6Q8T. Oh, we should normalize that, by the way, shouldn't we? No lowercase. That, and then if, so we have our ideal date, which is that. We want to import time here. Time. Expected date is time dot date. Not date. Protein is from time dot December 16. Four zeros after that. Time dot etc. Okay, and then we get this. Then if the expect time comparison compare is an equals time dot equal, nice. So expected date dot equal protein dot get date of deposition it doesn't equal, we want to complain, right? Let me do T dot. Not sure which. So let's go like testing. Should be some method here we should use. Error format. What it is, huh? T dot error f. We should use. I think Go recommends using a got % something wanted something. So we expect. Where's the other? I don't know. We'll just write we expected it to be equal. Expected 12, 16, 2018. We got. Maybe we just use %v to match any struct. Time. Protein. And that should, I think that's enough to tell whether that gets it right. QAT. What do we have here so far? Forget. This should put something in temp under this PDB directory. This is doing a lot. Wow. Oh, we're returning. This should return an error as well, I guess. So error. And then if error is not equal nil, we do tf. Error. Okay. And here, if error equals this, error does not equal nil, we return this empty struct. Open it. Scanner, we read a single line from it. Scanner.text. We parse it for so many lines. Strict error data definition. Is there some error here? So, oh, yeah, there is. This should be like date error. P and then here if it doesn't equal date. Okay. So we open this protein, that goes here, constructs just a struct. Let's also just default initialize the other things. The absolute path is that. Downloaded should be explicitly false. The other ones we can to construct a lot. I don't think so. We might have to actually. Yeah, I guess not. We don't actually have. Yeah, I think everything else is good. So when we do get that happens, there won't really be. Oh, so this just returns. Get just returns a protein. So we get date of deposition returns a time and an error. That's correct. And if there's an error in downloading, we'll know. If there's an error in opening the file, we'll know, because that means it didn't actually write it here. Know that too. Scan it, match it, see what comes of it. Condense this a little bit, I think. So we have date, like it's a string. We can just declare day, month, year to 0. I think we can do that. Then year. Because it exists outside the scope, we can just do if error, error does not equal nil, then do this check for us. Similarly here, if error does not equal nil here. So with Go, you can kind of merge these, like merge the lines between these conditionals. So originally we had this function call for argument to integer separate, so that we would call that function, we'd get a day and an error, but now we can just merge it into one. And the reason I declared this outside is because all the variables declared inside that conditional is local to that conditional. It won't exist outside the scope. So we have these, and then we can do, hopefully this is valid syntax. I think this is valid. I'm not sure. There's a lot of things. Let's see. 3 variables, but 1 value. Okay. Oh, I see. Okay. So it's 0, 0, 0. Right. Let's see. Test expected in line 16. Oh. Oh. Undefined. Okay. Go source. So 35. Oh, if p dot downloaded. Oh, okay. Oh, we didn't actually set the URL. Okay. So, a function that just did the. No, we have the ID string. We just add it. So we have the base URL plus the ID plus PDB. L should be const. I should fix that. 50. Here we'll return nil. 3. Oh, plenty of errors. Okay, so not enough arguments in OS open file. We want Elmo and oh, okay, so we just okay. Find scanner. Do we need buff.io? Define buff.io. Oh. Not use time dot. Use time dot January. Oh, okay. So month will be time dot. Default month. Is there a default? So you can't. So month and integer are aliased as types, but you can't just interchange them, which makes sense. Probably shouldn't have done. So I think I'm worried about if I just do January and it errors out. I guess then in that case I should have a default. Default will be to return an error, I think, because we couldn't match any of it. Logged on. So here. Okay, so now the problem is if we have time dot January as our default, but then it errors out, we want the default case in our switch case to do something about that, to report something. So I think we actually have to kind of maybe construct our own error. Error. This type is a string. This we an interface type. In custom error. Okay. Oh, really? Just create your own struct and return it? Oh. Hmm. This is a. Oh, maybe time provides a error. Oh, we could construct our own parse error. As a string representation. Message could not parse not in date. I don't know if this is even allowed. I hope it is. We shall see. $59. Oh, p dot. Oh, I see. This is so we're accessing our structs definition of scanner. Not parse. I use that argument. It looks like we're gonna have to add our own. No error. I like this a lot better. I want to write my own. Undefined P. Oh. Here we shouldn't be referring to this because it's in the same package. We just get. Multiple value. Okay, it's saying multiple value get date of deposition. Line 16. Oh, I see. Okay. That was wrong. So we want to do date here. It should be a got and old one. Got that. Want this. Got date. And we wanted expected date. Really? Declare not used, what? Dave is here. Declare but not used. That is incorrect. Oh. Oh, I see. Okay. Redo var error error. Here. Set error there. Dave. Here. That should do it. Right. So that's line 6. Okay, we're finally making progress. So it's saying the slash. Oh. Oh. Okay. So that's a good catch. So what's happening is when we do this past our join, these PDB file extension treats it like a directory. So that. At the end. Because that doesn't exist. We do ls temp b pd. It doesn't actually exist. Oh, because we gotta make it. Word. So when we download it, when we write it, we gotta check if PDB exists. And if it doesn't, we create it. That makes it. We want to test if the directory exists for. So we'll use make dir, but we also want to do is if is not exist. Oh, no. Oh. So we want to check the directory. Oh, stat, okay. Stat plus path stop. We stat this, it turns out this. So in that case, we create a directory, which is meter, and then we that doesn't work with actually creating it. So now we run a test. That's not right. It should be here. Non 41. Oh, I see, okay. Oh, 41. And it's lowercase. Permission denied. So let's see if it made it. PDB. Oh, in there. Oh. Right. So it made the directory, but there's nothing in there. Oh. So, permission denied when we tried to open it. We can't write to it. So it looks like permissions. Okay, so it turns out we're gonna actually have to change where we're storing our files. So we can't do it in there because say someone does some work, maybe that could work, but I'll just write it. Look for a new way to store temporary files. Now the reason we're doing this is, so the use case for this is if you're programmatically accessing PDB files, so ideally it shouldn't take up too much space in between restarts. So you should only be downloading the data that you need. The problem is if you need a lot of data, you don't want it to flush it too quickly. That's kind of what we're weighing here. So the temporary file system, so /temp, will clear it, I think, between restarts. It's not ideal for large batch jobs, which is super ideal for short jobs. So maybe user can specify what they want, and then by default we'll put it in temp. And then in the documentation we explain this and explain that for batch jobs with large data sets, specify, maybe we'll change things. I don't know. Something here will happen. Okay, that's something we'll explore on. We'll explore that tomorrow at 6. So yeah, so thank you so much for watching. If you stayed the whole 2 hours, it's great. This was kind of more of a test stream just to see if I'm speaking enough. I'm going to rewatch this right after and see if there are any changes I need to make. This will be on YouTube, so you can always come back to it. From this point on, we will be regularly streaming Sundays at 6 p.m. and it will be multiple hours, probably till like 11 a.m. Yeah. This is just so I can just honestly just write stuff. If there, and I'll eventually release forums and stuff that will allow the audience, you, to ask for certain topics to be explored. But for now, we're going to be exploring essentially bioinformatics and just looking at how computer science can help biology. Kind of what I've been doing recently. Yeah. So I'll see you all tomorrow at 6. All right.